Welcome back to the Python crash course. Let's get started with part 1. I'm going to hop over to a new Jupyter notebook to get started. Let's start off our crash course with the very basics, starting with numbers. So Python has two main number types that we're going to be working with. It has integers, which are just whole numbers, or what is known as floating point numbers, or floats, which is essentially just with decimals. And if you ever want to check the type of any object in Python, you just use the type function. So I can say type 1. I can see there it's an int for integer, or type of 1.0. And since it has that decimal information, it's a floating point number, or a float. Let's go through some very basic math with Python. So all of this you would probably expect to work. 1 plus 1, so that's addition. Multiplication is just an asterisk, 1 times 3. Division is just a slash, so 1 divided by 2. If you want to do exponents, for example, 2 to the power 4, it's just two sets of asterisks. We can see that's 16. The modulus operator, or mod operator, is just a percent sign, as it is in various languages. So 4 mod 2 brings back 0. And remember the mod operator, in case you're unfamiliar with it, it just returns the remainder after a division. So 4 divided by 2, since 2 goes evenly into 4, it just returns 0. And for example, I can do 5 mod 2. That brings back 1 because 5 divided by 2 has a remainder of 1. And then quickly, order of operations is followed in Python. So for example, if I have 2 plus 3 times 5 plus 5, here it brings back 22, but if I actually want the addition to happen before that multiplication, I can specify specific order of operations with parentheses. So here I'm going to say, hey, do the addition and then multiply them together. So now when I run the cell, I get back 50. The basics of variable assignment are also quite simple with Python. Python prefers snake casing, meaning if you have multiple words inside a variable name, you separate them out by underscores. So this is just by convention. There's no really strict rules on this, but we'll talk about this later on as well. But for instance, I can say equal sign. There's the name of a variable. So I can do this multiple times. So x is equal to 1, y is equal to 2, run that, and then I can say something like x plus y, and there I get the variables. Okay, so we talked about numbers and variable assignment. Let's quickly talk about strings. So strings can be a single quote or a double quote. So there we see strings with both single and double quotes. And for instance, if you wanted to say something like, I don't like that, you could just wrap it all in double quotes. So I don't like that. And notice now, even though I have a single quote here, because I'm wrapping the whole thing in double quotes, I don't get any sort of error. If I had done this with single quotes, then Python is getting confused because it doesn't know where your actual string ends and starts. So it says, oh, is this the string or is this whole thing the string? So you can just mix up these quotes, double versus single, to actually make everything work correctly. Now notice here, I'm actually getting in an output cell the string. If I want to actually display the string, I can print it, which means I can do something like print hello. And notice the difference here between just saying print hello or hello. If you're dealing with another IDE, you're going to be having to print your variables to see them during the output. For Jupyter Notebook, however, a lot of times it displays the very last line in a cell. So you can see here, it's just displaying that string. Versus here in this top cell in 20, it's actually printing out the string. So notice the difference here. There's no quotes, there's no out cell, versus here when I'm just asking for the string back, it returns the out cell plus the string itself. So that's printing, the very basics of it. Let's show you how to format print, which is essentially also known as string interpolation, which is a way to insert things into a string. For example, if I wanted to say something like my name is, and then leave some sort of space there for me to input names, I could do curly brackets and then off of this string call the .format method, and then I just pass in whatever I want to be there. So for example, I'll put in Jose. So we'll print this whole thing out. So put this entire thing under print, and now I can see it says my name is Jose. So this is known as .format on a string, or string interpolation for a general sense, but it's a way to insert objects into a string. And the curly brackets there indicate what's going to be put in. Now I can do this with multiple objects, and the way I can do that is by actually naming them or ordering them. So we'll say my name is blank, and we'll say my number is, and then we'll also have curly brackets there, and then I'll pass in a second argument inside a format, and I'll put in something like 10, but let's put it in as a string so we don't get any errors here. Okay, so I say my name is Jose, and then it says my number is 10. So I'm passing in that string 10 and then putting it in here. Now, if I don't pass it in as a string and try to run this, it also works, but you should be careful with that. Sometimes you may get errors if you try to add stuff together inside the string. So I'm just playing it safe, passing that in as a string. So that's a really common thing to do. Another thing to do with format is to actually label these variables, which you'll also see. Let me show you a quick example of that. So we'll say first, and we'll pass in x, and then say second, and we'll pass in y. So look what happens when I actually say for these things, x, 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 y, y, y. This is just to make it kind of really obvious what's happening here. Whoops, I get a key error because I actually labeled a key. So it expects a variable x to be inside format, and it will also expect some variable y to be inside .format. So let's add those in. We'll say x is equal to this triple x, and y is equal to this triple y. So running this again, now it works. So I see first, triple x, second, triple y. So you might be wondering, well, what's the point of this? Well, now I don't need to worry about the order things are in format, or I could use objects more than just once. For example, I could just say y. Now when I run the cell, it says first y, second triple y. Or I could reverse the order. Say y is first, and then second is x. Running this, I can see now I have a lot more control by actually naming these variables inside of .format. So that's the basic use case there. Let's move on to talk about lists. So lists are also known as arrays in other languages, and the way they work in Python is actually quite simple. All you have to do is use square brackets, and you separate the different items inside of the list by commas. So here I have a list of numbers, 1, 2, 3, but I could also have a list of strings such as A, comma B, comma C. So that's another list. And I can even mix data types. So I can say there's a number and there's a letter, run that, and Python doesn't complain. Now if I actually want to grab objects from a list, I can use indexing. So let's show you how to do that. I'll create an object called myList and set it equal to a list of letters. So we'll say A, B, C. Now as a really quick note, what you should never do is if you're typing a variable name and you notice that it's suddenly highlighted for you, then you're probably going to run into issues there because this basically indicates that this is some sort of reserved keyword. So if you notice that it's being highlighted, then you're having an issue. Now, if you've defined your own function and you expect that sort of behavior, then that's totally fine. But notice here it's being highlighted, so we're going to try to avoid using list as a variable name, which is a good call. And let me zoom in just a little more here so we can clearly see what's happening. So I have my list, it's equal to these A, B, and C. Let's say I want to grab the very first item in my list, A. Well, I can just use an index call. So we grab the name of the list, add in square brackets, and then indexing starts at 0. So if I want to grab the very first item, that letter A, I pass in a 0 there, and it returns the letter A. If I want to grab the very last letter, C, I have two options. I could count over and say 0, 1, 2, and pass in the number 2, and I get back the letter C. Or let's say this was a super long list, and I just wanted to grab the last letter, but didn't actually want to count all the way through. Python supports negative indexing, meaning I can say, okay, starting from 0, go backwards 1, which is essentially saying loop all the way around and grab -1. And there we have C. Okay, so that's the basics of indexing with a list. If I ever want to change an item in the list, I can index it and then set it equal to some new item. So we'll say my list of 0 is equal to new. And if I run this, I don't actually see any output. So let's check if my list was actually changed by just asking for my list in a new cell. And there it is. I have new B, C. So that's the way you can define a new or reassign an object in a list. Now, if I don't want to reassign an object in a list, but instead add on to that list, then all I have to do is use the append method, which appends a new item to a list. So let's show that. Going to clear that cell. Right now I have my list, which is new B and C, but I want to add a fourth item, so I'll say append, and then let's add the letter D. to the end of the list. So I run that. I don't get anything back since the action is not actually returning anything, but it is affecting the list. So if I ask for my list back, I can say new, B, C, and D. I can also nest lists. So let me show you what I mean by that. I can have my list is equal to, and I'm basically creating a new list here, 1, 2, and then the third item can actually be a new list. For example, 100, 200. So if I look at my list now, I see I have a list inside of a list. And you can do this as many times as you want. However, be reasonable. You don't want to do a nest inside of a nest inside of a nest, etc. But if you ever want to grab an item from this list, for example, let's say we want to grab 200 just by itself, well, I know that this list completely is the third item. So that's 0, 1, 2. So I pass in 2, and I get back that list, 100, 200, and I can actually stack index calls, meaning if I want to grab 200, well, that's index 0, index 1. So I just say this, 1, shift enter, and then I grab 200. So that's a nested list, and that's the way I can actually grab stuff from a nested list. I can just stack these index calls. So that's going to be useful if you're working with a matrix or something that has 2 dimensions. Usually that's represented as a nested list. So we'll see a little bit of this throughout the course, but it won't be anything too crazy. So that's the basics for all you really need to know about lists or arrays. Again, they're just a sequence of items or elements that are in order, meaning you can index them with a number. Now, let's talk about dictionaries, also known as hash tables in other languages. So dictionaries use this sort of notation. I'll say D is equal to curly braces, and then they have a key, which is always a string there, and then some sort of item. So this is known as a key value pair. So I'll have key, and then let's make a value 1. Then we have a comma there, and then we have key 2, colon, and then some second value. So I run that, and then if I want to access items from this dictionary, I pass in the key name. So what I want to do is access values based off of their key. So I'll grab a key here, key 1, and that returns value 1, which makes sense. And if I ask for key 2, then I get back value 2. So something to keep in mind that is sometimes confusing for beginners is that these hash tables or dictionaries in Python, they do not retain any order. So unlike a list, these guys don't retain any order. So whatever order happens to be printed out, so let's say I wanted to print out this dictionary, it may not actually be in the order that you would expect. So here, notice I get key 2, value 2, key 1, value 1, even if I defined it 1 and then 2. So again, dictionaries don't retain any order. And that really has to do with the way a hash table works, which you don't actually need to understand for this course. The basic idea is these are just key value pairs. So instead of items being in a sequence, they're matched up with key values as a pair. So you can easily access items based off their key. And this is a really great way to store things where you need really quick access. All right. Let's move on to discuss booleans. So booleans are quite simple in Python. It's just either true with a capital T or false with a capital F. Not much more to it than that. Now, as a quick note, a lot of programming languages, Python included, have what's known as truthy, which means if something is truthy or falsy, which essentially assigns some sort of truth or false behavior to a lot of objects. So for example, if you're ever working with if statements, which we'll discuss later on, and you don't really want to use a boolean, you can also use numbers. So zeros are treated as a false statement. So if you say if 0, it happens to be false, and ones are treated as a true statement. So if 1, then it actually does something. We won't see too much of that in the course, but if we do see it, I'll make sure to let you know. It's usually pretty obvious when you see it in actual coding. But that's something I want you to be aware of. Now there's 2 more data structures I want to discuss. That's tuples and sets. Tuples are very much like a list. They're a sequence of items, but notice here that they're defined by using parentheses instead of these square brackets that we saw earlier. Now you might be wondering, well, why use a tuple versus a list? Well, tuples are immutable, meaning you can't reassign the items inside of them. So I have t of 0, and if I try to set this to new like I did for a list, I will get a type error, and it says tuple object does not support item assignment. So you want to use tuples when you want to make sure a user can't actually change anything inside of this sequence. So that's the use case of a tuple. And then finally, the last major data structure of Python is the set. Looks a lot like a dictionary, except there's no key value pairs. It's just this sequence of items. So a set is an unordered collection of unique elements. So what does that mean? It means since all the elements have to be unique, if you add in multiple instances of an element inside of this set, it's going to reduce this to just the unique elements, which is 1, 2, and 3. All right, that's really all we need to know as far as the basic data structures, and we'll constantly be reviewing this sort of stuff as we continue on throughout the rest of the course. And a lot of the syntax we'll be using is mainly with Spark data frames, so this is all you really need to know. Coming up next, we'll discuss comparison operators, logic operators, and then how Python deals with if, else if, and else statements, as well as certain loops like for loops and while loops. Thanks, and I'll see you at the next lecture.